My name is Jovica Popović. I'm a developer evangelist at Avalanche. This is my Twitter handle. So, what is Avalanche? I guess if you're familiar with Avalanche, you can now scroll your phone for 2 minutes without any guilt. Avalanche is a third wave of blockchains. It is from the start envisioned as a network of networks, so the old paradigm of a single chain and single execution environment to work for all use cases obviously doesn't work for all use cases. The main innovation that Avalanche brought is the Avalanche consensus, which brings many novel features that were not available in previous consensus protocols, and it is the first novel protocol since the Nakamoto consensus in 2009. Avalanche also enables modular execution. As we said, if we want to have a network of networks, not every application will have the same needs for its execution. And Avalanche enables horizontal scalability. Just how it does that, we'll get into it in a bit. So, Avalanche consensus, a couple of points about its features. The biggest is Avalanche enables true decentralization, because you can have hundreds, thousands, even 10,000 validators all validating a single chain and a single stream of transactions without losing any performance. So you can have 10,000 validators and still have a working chain that works in real time. Avalanche also enables very fast finality. On the main network right now, finality for blocks that are posted is less than a second. So that is a pretty important capability for a blockchain application, because you don't want to post a transaction and then have to wait 30 seconds, 2 minutes, or an hour before you know that transaction is valid and accepted on the network. Right now, Visa, which we all look as a holy grail, has something like between half a second and 2.5 seconds to finality. So Avalanche is on par with Visa right now. Avalanche is also green, which means it doesn't use too many resources in its functioning. And it is also quiescent, so if you don't have any transactions going through the network, you don't have any blocks, so there's no unnecessary work being done. Avalanche consensus itself is a whole family of protocols, each tailored for a particular use case, some that work well in non-adversarial environments, some that work in validating a single totally ordered chain, some that work in validating a direct acyclic graph, which enables parallel lines of execution and very high throughput, and some that enable congestion control, which you also want in some use cases. So, Avalanche launched something like 20 months ago, and let's see how it's doing right now. We started with about 100 validators, and right now we have 1,600 validators thereabouts. Those are 1,600 totally independent validators, each validating every block and every transaction in real time. This is very distributed all over the world, not a couple of data centers or many validators on single machines. We also have more than 20,000 delegators. So those are AVACs that are delegated to one of the 1,600 validators to help secure the network. As far as the transaction count, we are right now doing something on the order of 1 million transactions per day, or at least until the recent crash, but yeah, you know how it is. All the fees on Avalanche are burnt. That means they are destroyed and taken out of circulation, and basically raising the value of every other AVAX there is. And since the mainnet launched, we have burned more than 1,600,000 AVAX. The performance of the network. So these are real world mainnet performance numbers. The network can pull in even with the congestion control over 200 TPS, and way back when we didn't have any congestion control, it even went to more than 800. Again, this is real world, real transactions, not in a lab or in a test setup. Average TPS is somewhere around what Ethereum does for a fraction of a price. And all of this led to quite well market uptake. So at the highest peak, I think we had something like 15 billion TVL. Right now, obviously, due to the market, it's somewhat lower. But the market has recognized the value that Avalanche brings. And this is usually the point where all the other solutions that cannot scale run into problems. And this was also the case with Avalanche. First, we had capped gas price, and then we, as the technology capabilities evolved, we let the gas price move freely with the situation on the chain demand. So we had at peaks gas price going up to 2,000 nanoAVAX, which translated to something like $5 per transaction, and that obviously is not very good for anybody. And so that will be it for if we didn't have a good solution for scaling. And fortunately, this is where subnets come into play. What are subnets? Subnet is a dynamic set of validators that come together to validate one or more blockchains. So all the subnets have their own separate state, networking, and consensus, which means in practicality, whatever happens on a subnet stays on the subnet. So if you run your own subnet, if another subnet is having a huge NFT sale and it peaks 10 times usage than regular, your own subnet doesn't know about it and it's not affected. Same as the main chain. So subnets are sovereign, which means that are completely isolated from the rest of the network, which also means that the risk is isolated. So your own subnet will not suffer from some other subnet being reckless with whatever they do and bring down their subnet. Your own subnet will not be affected. And most importantly, subnets inherit all of Avalanche's capabilities. So on your own subnet, you will have sub-second finality. You will be able to have thousands of validators. You will be able to have multiple chains running different execution models, everything that the primary network also does. So let's dive a bit deeper into some of these capabilities that show that this is in fact practical horizontal scaling. First is the custom execution layer, meaning execution layer being the application level logic of your blockchain. Virtual machine is an arbitrary execution rule set that determines how your network moves from one state to the other. That is how are transactions constructed and validated. And on Avalanche, you can have your own custom VM rule set, basically your own modular execution layer. You don't have to worry about networking consensus on state storage. This is all provided by the subnets. You only have to think about what your own VM needs to do. And each VM launches its own blockchain. and in a single subnet you can have multiple VMs running blockchains, so you have capabilities more than a single VM will enable you. Currently, we have a couple of VMs developed. The first is the subnet EVM, which is the Ethereum virtual machine that runs in the subnet context. The second is Avalanche VM, which is what we already have on the exchange on the primary network, which uses direct acyclic graph and has very high throughput. We developed Spaces VM, which is a key value storage as a way to show that you don't even have to have a blockchain that is a series of blocks. You can have a VM that uses key value storage. Also, you can have a blob VM, which is a binary storage. So you can store your own arbitrary binary data in your own VM, in your own subnet. That enables incredible creative possibilities. We also developed a timestamp VM, which is basically minimum viable VM, which is a shell of all the necessary capabilities that you need to be able to launch your own blockchain, but nothing else. So this would be a good first step to start if you need to develop your own VM. And basically, whatever you make that implements this RPC chain VM interface can be used as a VM on Avalanche. So the possibilities are basically endless. Of course, EVM is the most popular virtual machine right now. Solidity is the most popular smart contract developing language. This is a bit of a misnomer because subnets actually are not EVM subnets. Subnets run blockchains, and blockchain can be an EVM, but this is a handy way to show that you can have your own Ethereum, but better. So what's better about this, your own private Ethereum? First, you run your own gas token. You determine how is gas paid on your own subnet. It can be your own token that you completely control, which means that you have sovereign tokenomics on your own subnet. You can also have custom validator requirements. So if you want to run your subnet very hot and very fast, you can require that validators on your subnet need to have beefy hardware. Or you have some specific VM that you want to run, you can require that every validator needs to have a specific graphics card or be located at a particular geographic location or something like that. You can define your own custom block rate and gas targets, which means that you can basically design the TPS the way you want it to be. And finally, you can have your own custom set of precompiles, which precompiles are what is used to make EVM work for you. This is something that is actually already available on Ethereum as legacy precompiles, and that's a way for you to extend the functionality of an Ethereum virtual machine by adding specific functionality functions that you send arbitrary data to and get some arbitrary data in return. Currently, there are a couple of precompiles already active on Ethereum, and those are mainly used for computationally expensive things that you wouldn't be able to do in Solidity, or it would be either impossible or very gas uneconomic. So various hashing functions, cryptography, and things like that. Since that already exists, doesn't look like a great feature, but the thing is, besides all the standard precompiles available on Subnet EVM, you can also add your custom ones. Right now, you can do that on Ethereum. You only have to convince the whole world to do a hard fork of the network and add your own specific code, and everybody in the world upgrades at the same time, so basically impossible. But if you run your own subnet, you can create your own precompile, add it to your own VM, and launch and have any kind of extra functionality that enables your particular use case. So for example, if your game needs some sort of fancy 3D trigonometry, you can add your own precompile to do that. And of course, at Ava Labs, we always like to go a step further. So the thing we did was we added stateful precompiles. Legacy precompiles, as they are available on Ethereum, do not have access to the state of the chain. So you only can send to the precompile, you can send a series of bytes and get a series of bytes back. But with stateful precompiles, you also send a pointer to the current chain state, which enables you to do any kind of transformation of the chain state in your precompile. This is an extremely powerful capability, and it also allows you to break out of the EVM, for example, to talk to third-party services and things like that. This enables a whole host of possibilities that we only have scratched the surface on. So right now, to test out that functionality and enable a couple of use cases that we thought of and our partners wanted, we have a couple of stateful precompiles already available. The first is contract deployer allow list. So let's say you have your own subnet running a game, and you have a smart contract that controls that game. If somebody else can deploy a contract that can interact with your own contract, with your own game contract, they can probably do something malicious like take advantage of your users. So you may not want to allow just anybody to deploy a smart contract on your own subnet. We created a contract deployer allow list that allows you as a subnet owner to specify a list of addresses that are allowed to create new contracts. That means you completely control the execution of everything on your own subnet. This is a pretty powerful function. But we can also go a step further. Let's say you're a big financial institution and you have a charter that only allows you to work with US citizens. So you obviously cannot have a permissionless network because you need to have some way of determining who is the person that is interacting with your subnet. That's why we created a TX allow list, which is a precompile that allows you to add addresses that are allowed to post transactions on your own network. So whenever your user that has some requirement or geography or being, I don't know, certified or something, does the KYC with you, you add him to the TX allow list, and then that user can interact with your own subnet. Another precompile that we added is the native minter. So on Ethereum, the only way to create new tokens is through block rewards. That might work or might not work for you. So we added a native minter, which is a precompile that allows you to to mint additional amount of your own gas token, which can be useful for you if you have a specific tokenomics in mind that the block reward would not cover. And of course, as Uncle Ben said, with great power comes great responsibility. This is an extremely powerful feature, but it's also an extremely powerful foot gun in that it allows you to shoot yourself in the foot if you're not careful. So if you're doing anything with stateful precompiles, please talk to us. We'd like to help you not shoot yourself in the foot. Also you can have the best system in the world, and if your system is not created in a way that allows programmers to work on solving problems, but makes them work on the infrastructure, that won't be a good experience. That's why we are creating what we like to call Subnet Starter Pack, which is a set of services and the capabilities that allow you to quickly get on your feet and start working on your actual use case and not on the boilerplate and things around what is not important. That means you can use familiar Ethereum development tools from Hardhat, Truffle, Remix, I don't know what have you. Also, we took great care in creating a set of tools that allow you to work easily with subnets. One of them is Avalanche Network Runner, which allows you to quickly, with a single line in the command line, spin up a whole Avalanche network on your own, locally on your own machine, that you can deploy a subnet to or smart contracts and interact with it with all the usual stuff that you use as a developer. The next one is Avalanche CLI, which is a command line tool that allows you to create quickly new subnets with whatever virtual machines and setup you need, Genesis and things like that you can either run locally or deploy on a testnet and even later deploy on the mainnet. All of this creates a very easy local to testnet to mainnet flow that is essential in going from an idea to production. Sorry. We also developed a set of auxiliary services that you need to have a functioning network. So the Explorer, the RPC, the Faucet, those are all services that you cannot do work without them, and your users will not be able to interact with your subnet in a satisfactory way. As well as we have a series of partners that allow you to easily integrate wallets, DEXs, and bridges to your own subnet. So we try to solve all the problems that are not your actual problem that you want to solve when you think about running a subnet. So all of this is a nice story, but we hear nice stories all the time. The real question is, does it work really? I mean, you can have a nice story, but without execution, it's worth nothing. So we have a couple of examples that show what we're making really works. So first is the DeFi Kingdom Subnet, which is a game that started originally on Harmony Network, and where they had 80,000 monthly active users, did some 200,000 transactions per day, but for various reasons they weren't too happy with the Harmony Network, and they wanted to come over to Avalanche as a subnet. The other example is the Swimmer subnet run by the company that does the Krabada game on Avalanche. That is a native project that started on Avalanche and grew until it outgrew the C-chain capabilities. Although it has 10,000 monthly active users, it does some 400,000 transactions per day on the network, which obviously wasn't very good for the main chain because it raised the prices of gas for everybody. So let's see how those subnets, once they launched, what was the effect. This is the DeFi Kingdom subnet. When they launched, and my pointer is not exactly working, they added some 20 to 30% in average gas spent and daily transaction count to the Avalanche platform. But at the same time, this is the graphs from a node that is not on the DeFi Kingdom subnet. This is a resource utilization node graphs from a validator on the primary network, and only primary network. So this is the point where DeFi Kingdom subnet launched, and where they had this spike, and this is what it looked like on the validators that is not on their subnet. It was completely unaffected in CPU, in memory, and in disk usage. So it was not in any way interfering with the rest of the network. When the Swimmer networks subnet launched, as they were doing some 400,000 transactions per day, on an average day they were doing like 30% of gas usage on the network, which ran all the fees up. And when they switched to their own subnet, this is their transactions, which even went higher than they were before, but at the same time, gas prices on the main network went to their minimum. This is the great crab migration spike, where everybody just moved to their own subnet, and after that, the fees on the main chain were basically at a minimum. So right now, the transactions on primary network on C chain cost like 2 cents. And as we can see from those examples, from adding completely new capability or moving capability from the main network to a subnet, it works. And these were the data from a couple of days ago. So on the primary network, we have 250,000 transactions, and on the only 2 subnets, we have 3 or 4 times as many. But still, the transactions on the primary network cost 2 cents. Transactions on all of the subnets are sub 1 cent, and this is all working without any problems. So in the last month or so since they launched, DFK made 11 million transactions. Swimmer network in like 3 weeks did some 5 million transactions, and this all works. So Avalanche is the network of subnets. Thank you. If you have any questions, and these are some useful links you might have.
Hi, I'm actually a little curious about the fee structure. Like, as a developer, if I open up my own subnet, what does that look like?
The fee structure is, you mean, is it burn, is it accrual?
Like, you guys would obviously take something, right, from me using your subnet?
Nope.
No.
The value that the subnets bring to the primary network is in the fact that every validator needs to be the validator on the primary network, which in turn means that it needs to stake at least 2,000 AVAX on it. So the value accrual is there. You run your own subnet, you design your own tokenomics and gas prices and congestion any way you like it. You can burn all the fees like Avalanche does, or you can burn a portion of the fees and some of them leave as a reward for validators, as an incentive, and things like that. But the network itself does not interfere with whatever you do on your own subnet.
Thank you. Nope.
Hey, so what's like the difference between the subnets and the Polkadot parachains? Like, if you can explain it.
That is a bit of a long answer.
So in short story?
You can have 10,000 subnets. You don't have to ask anybody to create a subnet. You don't need $10 million to pay to the network to create your own subnet. You can have 10,000 validators on your own subnet, and it will still run with sub-second finality, and it will still have as much TPS as you configure your network. One other thing is there is no forced shared security. That is usually one of the talking points. Oh, you don't have shared security. Yeah, but shared security is also shared risk. If you were on a network that had Luna, with shared security a couple of weeks back, you wouldn't be having a really good time right now. If you were divided with them, the fact that they fail, like for example, Cosmos continued working with Luna imploding. So risk isolation is pretty important, and Polkadot doesn't have that. So those will be the couple of main points. We could go on discussing further, but
thank you for the amazing talk. I had a question. If the subnets are protected by staking AVAX, aren't the validators able to do an honesty arbitrage once the TVL of the subnet surpasses the staked amount in AVAX, or AVAX simply falls in value?
I suppose so, but that would be more of a. I'm not much of an economics guy, so I wouldn't be able to answer that satisfactorily.
No,
sorry.
asking just from the perspective of security.
There is no mechanism that would create a great inflation in AVAX, like for example it was a situation with Luna. But if the price crashed to, I don't know, 1 cent, you will still need to accrue those tokens somehow. So, but I'm not sure what's the exact game theory there. Sorry.
Thank you.
Let me rephrase the Polkadot question. So how would you compare subnets to Cosmos chains, since they have no shared security?
Again, I would have to say that Avalanche consensus has some advantages in the Tendermint compared to Tendermint consensus. You can have 10,000 validators on a single chain. In Avalanche consensus, you can have at most 200 validators on Tendermint before the message passing complexity makes it unviable and ruins your finality time and things like that. So that would be the main reason. There are others, but I wouldn't go into them. It would take too long right now. So. One more question?
Yeah, I can go without the mic. Can you just talk a little bit about the actual connection between subnets and the main part of the Avalanche?
So right now there is no platform-enabled cross-subnet functionality. That is planned on a roadmap down the road. But currently, as if your subnet is running an EVM, you can use any kind of bridging technology that is available on Ethereum or other EVM-compatible chains. So, for example, I think DFK uses Synapse, Krabada uses Layer 0, and we have other partners that are happy to provide bridging services to your project. So
I was thinking about the connection between subnets and Avalanche's main structure. I don't know too much about Avax, so I guess it's the C chain and the P chain and the K chain. Is it like Polygon doesn't use their own POS chain, like the checkpoint idea, or how does it work?
no, as I said, there is no shared security there. You need to create your own bridge that has a certain trust assumptions that hold and isolate the risk between other subnets and your own subnet and the primary chain. So, okay, that's it. Thank you.